Hello everyone. Welcome to this lecture on Introduction to Programming using Scilab. This is the first lecture of the free course on programming using Scilab, and this is part of the free course series organized by LearnCAX. Many more lectures of this course will come up in the weeks to follow, and through this course you'll be able to get introductory knowledge to programming using the software Scilab. So before we start this lecture, the first doubt that will come to your mind is, what is this course all about? This course is about the software Scilab. As you can see the Scilab console, this course will teach you how to do programming using this particular software, which is a platform for programming languages. It will teach you the software environment, it will teach you the basic functions, the basic syntax of the software, and how to extract images or plots from the software. For whom is this course ideally designed for? This particular course is meant for beginner programmers. It will provide introductory knowledge about programming, and the platform that we are going to use in order to teach programming is Scilab. This course is for all those who are curious about computers, programming languages, open source, and want to gain some knowledge as well as have some fun while doing the same. So if you are interested in computers, programming languages, open source, and want to gain more knowledge about any of these, this is the course for you. So we are talking a lot about programming, open source, Scilab. What exactly is the Scilab? Scilab is a software for numerical computation. It provides a computing environment for engineering and scientific applications. And it is very similar to the software MATLAB. So it is like an open source alternative to MATLAB. The best thing about Scilab is that it is free and it is open source. What can Scilab do? Scilab includes hundreds of mathematical functions. It has a high level of programming language which allows access to advanced data structures, 2D and 3D graphical functions. So it is sort of a all-in-one programming platform. Large number of functionalities are included in Scilab, and you can do maths and simulations, 2D and 3D visualization, optimization, statistics, control system design and analysis, signal processing, application development, and there is something called as hybrid dynamic system modeler and simulator. So you can actually do system modeling and simulation within Scilab. So Scilab is like a clone of MATLAB, but it is open source and it is free. So let us take a look at these features one by one. First we'll see maths and simulations. Scilab provides about 1700 mathematical functions for user engineering and scientific applications. This includes functions for mathematical operations and data analysis as well. It has elementary mathematical functions, linear algebra, sparse matrices functions, polynomials and rational functions can be done. Simulation can be done of explicit as well as implicit systems on differential equation. If we take 2D and 3D visualization, MATLAB provides graphic functions for visualization, annotation, and exporting data. We can create and customize various types of plots and charts, line plots, pie charts, histograms, surfaces, animations. We can also have LaTeX or MathML annotations. Graphic export is available in formats like PNG, PPM, EMF, etc. If you want to do optimization using Scilab, there are algorithms to solve constrained and unconstrained continuous and discrete problems. We can do non-linear, quadratic, non-linear least square optimization, semi-definite programming, genetic algorithms, simulated annealing, linear matrix inequalities can be solved. In statistics, Scilab provides tools to perform data analysis and modeling. We can do descriptive statistics, probability distributions, linear and non-linear modeling. For control system design and analysis, Scilab provides standard algorithms and tools for control system study. There are transfer functions, classic and robust control, stability analysis, state space control system design. For signal processing, Scilab provides tools to visualize, analyze and filter signals in time and frequency domain. Signal generation, data windowing, power spectral density estimation, analog filter design, all these can be done using Scilab. And if you are looking into application development, there is API enabling to increase its native functionalities within Scilab. So you can increase the native functionalities of Scilab, and also there are tools to create your own modules and deploy them. There is advanced data structure and user-defined data types. You can create user-defined GUIs. There is interface with Fortran, C, C++ and Java. There is API for calling Scilab from C, C++ and Java. Dynamic build and linking options. There is also something called as automatic modules management for Scilab, which we will see in detail when we see features of Scilab in detail. And testing framework is available within Scilab. So it is a complete environment for application development as well. And Scilab acts as an excellent platform if you are going to do programming languages using third-party technologies and applications. So Scilab can act as a unique platform to bring together codes written in different programming languages. It can generate a unified language, thus facilitating their distribution, and we can also back up the program using Scilab. The main Scilab functionalities can be extended by calling from Java, Python, Fortran and C. And it offers many components to facilitate previously developed code. So if you have developed a code using any of the languages like C, Python, Java, Fortran, you can actually import them in Scilab, and Scilab helps to reuse or modify those programs. So we will see what are the three things that define Scilab. First is programming software. So Scilab is actually a programming software. If you look into programming language community, there are lots of programming languages which have been invented and which have evolved. So Scilab basically is a platform for programming language or programming. Scilab is open source. So open source means it is available freely for download and for use. As you can see here, open source is something that is hassle-free. Open source does not come with any headache. So Scilab is open source, and when we say that open source, it means that it is available freely for download and use. And as you can see, open source is something that is going to be the future. That is going to be a parallel with paid technologies, and that is going to compete with paid technologies. And this is clearly an indication that open source is going to grow, and open source technology use is going to be something that is considered to be cool and more user friendly. And Scilab is meant for simulations. So simulations is the thing that we are dealing with in many of our other lectures as well, and Scilab is directly connected, or it is a tool for building simulations. So what we are going to do is we are going to take these three things, that is we are going to take programming languages, open source and simulations, and we are going to go a bit detail into those. So first what we are going to do here is take a history tour of programming languages. We are going to see how programming languages were invented, how they grew, how many programming languages came into picture, who invented them till now, what were the different programming languages and what was their impact, and nowadays what is the picture of programming languages as such. So if you consider the 19th century, it was the century of industrialization, where United Kingdom was the first country in the world to industrialize. Mechanical power was considered to be the invention, and many different mechanical machines came into picture, and the industrialization of the entire world happened in the 19th century. And during the same century, how did computer look like? Well, this is what computers look like in the 19th century. They were basically mechanical machines, not like computers that are there today. So the first computer was the first computing engine was the reference engine. It executed tasks by changing gears, which executed the calculations. So this was sort of a programming or calculating machine, or the first calculator or the first computer that is known. It is the earliest form of computer language, which was physical motion. So the computer language was actually physical motion here. It had a lot of gears and which made polynomial function calculations, and it was the first automatic computing engine. Now we will see a demonstration of the Babbage engine. This is actually the replica of the Babbage engine, which is at the Computer History Museum.
Every turn of the engine's driving handle is carried through gears, cams, rods, levers, and springs to release and arrest precisely aligned number wheels. The helical arrangement of steel fingers continually tolls the register towers to find and perform the carrying of tens. In its continuing sweep upward, it is mesmerizing. The intricate printing section can be programmed for 1, 2, or 3 column output, for 2 font sizes at once, for variable margins and column gaps, even word wrap where necessary. In the spring of 2008, a clone of DE2 commissioned by Nathan Myhrvold was completed at the Science Museum and shipped to California. At the Computer History Museum, it would charm new thousands of discerning eyes. Today, the crotchety proud genius, who never managed to prove it during his lifetime, has a fair claim to honor as a pioneer in the history of intelligent machines, just as his parlor guests in 1832 suggested. His difference engine continues to inspire the admiration of his intellectual heirs, a celebrated and unique icon to chroniclers of computing. Charles Babbage, remember, never saw it, except in his stubborn, prescient dreams.
Who invented the difference engine? Charles Babbage was the inventor of the difference engine. As you can see, he was English polymath, he was a mathematician, philosopher, inventor, and a mechanical engineer. His aim was to develop a fully programmable computer, and he started with the difference engine, which was a sort of a mechanical calculator. If you want to read more about Charles Babbage and the difference engine, these are the books that you can go through. Charles Babbage, Pioneer of the Computer by Anthony Hammond, and Charles Babbage and the Quest to Build the First Computer. So this is also an interesting book to go through and read about Charles Babbage, his work, and the difference engine. Then came the 20th century, where man went to the moon and changed a lot of things on the earth. The earth looked totally different after lots of inventions that happened in the 20th century. So this is a sort of a very familiar picture that you must have seen earlier as well, which shows sort of evolution of human or mankind and how computers have actually made us go in the reverse direction of evolution. So this is a common joke or a common anecdote that is used in order to define how man became a dependent on computational technologies or computers. But actually this is what is happening. In a positive way, computers have helped us to get back to our feet, because invention has actually taken a pace to suit human technology, to help humans, and to make them much more independent or much more stronger. Because computers have not remained like blocks that are shown here, but they have actually become handheld devices nowadays. So in the 20th century, in 1942 came the second sort of a computer or computing engine known as ENIAC. In this, the physical motion was replaced by electrical signals, and it followed many of the same principle of Babbage engine. What basically these machines, the computing machines, do is that they use gears and a lot of mechanical motion in order to make polynomial calculations, in order to make simple calculations for functions. And what it required is presetting switches and rewriting the entire system for a new program or calculation. The long form of this is basically electronic numerical integrator and computer. And this was basically invented to calculate artillery firing tables for the United States Army's Ballistic Research Laboratory. Who invented the ENIAC computer? It was John William Morley and Presper Eckert. John William Morley, who is an American physicist, along with J. Presper Eckert, designed the ENIAC. It was considered to be the first general-purpose electronic digital computer, and together they started the first computer company, which is the Eckert-Morley Computer Corporation. They pioneered fundamental computer concepts like stored programs, subroutines, programming languages. If you want to read more about these two inventors as well as their invention, that is ENIAC, you can read this book by Scott McCartney, which is an interesting bibliography or an interesting compilation of how the ENIAC came into picture, how it was invented, and what was its effect. It is also considered as among the first computers of the world. In 1945, a very important inventor known as John Von Neumann developed two fundamental ideas which have affected the entire computer or programming language world. First idea was shared program technique, which said that computer should not need changes done to its hardware to run a program. Rather, it should be freely programmable, which means even if you write a different program, the computer hardware should not need any changes. The hardware should remain same. There should be some link between program and the hardware, which will be able to convert that program into a language or into instructions understood by the computer. Because what was happening till now is that the hardware was changing for every different program or calculation. The second concept that he developed was conditional control transfer, which means code, that is computer codes, can be put into small blocks which do not have to be computed sequentially but can be accessed according to the conditions in the code. So rather than writing a single chronological code, code can be written in any flexible manner that one wants, and small blocks, the code should consist of small blocks which can be called whenever they want, which can then later function on themselves and help the code to go forward. Due to these two concepts, due to these two ideas, concepts like subroutines came into existence. If expressions, then loops, for statements also came into existence because of the work of John Von Neumann. His work also gave rise to the idea of libraries, which are blocks of codes that can be used over and over again. Several computers after this came into picture, like the ORDVAC, EDVAC, and these were all built more or less on the same concepts or ideas that John Von Neumann invented. And these machines were programmed by feeding them zeros and ones on a punching card, which was the new invention or the new technique of programming data. Who was John Von Neumann? He was a pure and applied mathematician. He made a major contribution to the field of mathematics, physics, economics, and computer science, and he was a key figure in the development of game theory and digital computer. If you want to read more about John Von Neumann, these are the recommended books for the same. One is The Scientific Genius Who Pioneered the Modern Computer, Game Theory, and much more, which is by Norman Macaire. And the second is John Von Neumann Selected Letters, which is also a highly readable book. So after these inventions, the first programming language came into picture in 1949, which was known as short code. It was not a machine code, it was the first non-machine code or programming code. It was the first computer language for electronic devices, and although it required the programmer to change statements into 0 and 1, so it was not totally independent of human intervention, it required the programmer to change the statements from 0 to 1, but it was not a machine code. And because it did not have physical motion as its main working principle. Still it was considered to be first step towards complex languages that we see today. It provided basic arithmetic and allowed for branching and calls to library based on John Von Neumann's principle. After that, in 1951, the first compiler came into picture. A compiler is basically a program, as we all know, that turns the language statements, that is programming language statements, into zeros and ones which can be understood by a computer. So because of the invention of the compiler, faster programming happened. And after this invention, programmers no longer had to work by hand. So it basically made programs independent of human intervention. And the first programming compiler, or the first compiler, was known as A0 system, which is arithmetic language version 0. And it was the first ever compiler designed for electronic computers. The A0 function, the A0 compiler actually worked more of as a loader or a linker rather than a modern compiler. Who invented the A0 compiler? It was Grace Murray Hopper. She was an American computer scientist, and she invented first compiler for computer programming languages. It was a machine-independent programming language, and she is credited also with inventing the term debugging. Whenever we say today that we have to debug a code, she invented the terminology debugging. If you want to read more about her, there is a good book called as Grace Hopper and the Invention of the Information Age by Kurt Bayer, which is worth a read. So this was all about this particular lecture, which we will end here. What we will see in the coming lecture is we will continue the history tour of programming languages. We will see how C programming language was invented, how it grew, who invented it. We will see how Fortran came into picture, as well as how open source terminology came into picture, how the open source community grew, and what was the history of open source. After that, we will try to answer why simulations are needed in the mathematical or industrial domain. After these, we will enter into programming, into learning programming using Scilab. So thank you for attending this particular lecture. We look forward to seeing you in the next lecture of this Scilab course as well.